Let's talk about limits to infinity of rational and polynomial functions. So we already have an example on the screen that will find the limit as x approaches positive infinity of 3x to the power of 4. The simplest step we can simply take is substitute this limit value here. This term becomes equal to 3 open brackets. We substitute the infinity sign for the x here. So we have infinity to the power of 4. Now this is equal to 3 times infinity to the power of 4 happens to still be infinity. So we have infinity here. And then 3 times infinity is still also infinity. Let me quickly take another example to help us understand more. Say we are asked to find the limits of minus 2 over 5 x as x approaches infinity. To do this, we simply did as we did before. We say, okay, this would be equal to, we plug in the infinity for the x values. So we have minus 2 over 5. And then we have our infinity. So here we have, this is equal to minus 2 over 5 times infinity. Now there's the negative sign here. The negative sign can affect the infinity, such that it will look like equal to minus 1 times infinity times 2 over 5. Minus 1 times 2 over 5 is still the same thing as 2 over 5. So that if you have minus 1 times negative infinity is equal to negative infinity times 2 over 5. So negative infinity times 2 over 5 is negative infinity. So if you have a positive infinity and you multiply it by minus 1, you get a negative infinity. Let's take another example. Say we are asked to find the limits of 2x cubed as x approaches negative infinity. Now you can pause the video and try to solve this one yourself. Like we did before, we plug in the negative infinity into our function. So this is equal to 2 open brackets minus negative infinity cube. So this is equal to 2. Now negative infinity cube is, or you can simply write it as negative infinity times negative infinity times negative infinity. Now minus can cancel out minus, but we'll still have another minus. So we have negative infinity times infinity times infinity. This is essentially 2 times negative infinity. Now 2 times negative infinity is still equal to negative infinity. To help you for future steps where you have negative infinity powered, if you have an odd number power, your negative infinity still stays the same, like we had here. If you have an even number power, like minus negative infinity square, it will be equal to positive infinity. But if you have an odd number power, like negative infinity, then you have 3 here, or 5 here, or 7 here, the answer will still be negative infinity. So let's move to more complex examples. So let's say we are to find the limits as x approaches infinity of 1 over x. The answer to this question is equal to 1 over infinity, and then we have equal to 0. But why is it equal to 0? So think of it like this. Infinity is just a very, very large number that we cannot comprehend. So if you think of it like this, this function is 1 over x. Let's stabilize values. So let's say we have the function 1 over x and we decide to plug in various values for x. What will be the resulting answer? So let's say we come into the function and we say, let's put in 10. If you put in 10, 1 over x will become 0.1 here. So that means 1 over 10 is 0.1. If you put in 100, 1 over 100 is 0.01. Put in 1000. 1 over x will be 0.001. Put in 100,000. Would have 0.00001. So if you notice, the more we increase the value of x, the closer our function of 1 over x gets to 0. So that's why 1 over x as x approaches infinity is 0. We need to note this idea because you're going to be using it over and over again when you're dealing with limits to infinity. So what if you're asked to find the limits of 1 over x as x approaches negative infinity? How would it still become? The answer will still be equal to 1 over negative infinity. 1 over negative infinity is still equal to 0. So if you still do the tabulated form, as the value here is increasing, this number will be approaching 0. So the answer to this limit is 0. You can also pause the video and try the same tabulated form we did for this previous question here. So let's look at more polynomial examples. So what if we ask find the limits as x approaches infinity of minus 2 x to the power of 5 minus 8 x to the power of 4 minus 7 x to the power of 3 minus 10. If you have a polynomial function like this, the first step to start is to recognize the x value or the variable value that has the highest degree. So here the degree is 5, here the degree is 4, here the degree is 3. So you find the one with the highest degree. Here there is no degree of x. The one with the highest degree is this one. Now we have to factorize this one from the rest of all these terms here. So I'll have to write this limit. So I'll say the limits as x approaches infinity is minus 2 x to the power of 5, open brackets. You have minus 2 x to the power of 5 over minus 2 x to the power of 5. You have minus 8 over x to the power of 4 over minus 2 x to the power of 5. You have minus 7 x to the power of 3 over minus 2 x to the power of 5. You have minus 10 over minus 2 x to the power of 5. I bracket that so that this cancels out this. We have a positive 1 here. This cancels this. We have a positive sign here. This against this, we have a positive sign here. This against this, we have a positive sign here. So from here, I have 2 cancels out 2, and then x to the power of 4, x to the power of 1, x to the power of 4, x to the power of 5. We have x here. Here, x to the power of 3, x to the power of 5. I have x to the power of 2 here. 7 over 2 stays. 2 here, 5. 2 here, 1. So I have my x to the power of 5. So if I'm writing this thing, it becomes the limits as x approaches infinity of minus 2 x to the power of 5, open brackets, 1, plus, what did I have here? This is 4 over x, then I have plus 7 over 2 x squared plus over x to the power of 5. So if you notice, we have some fractions here that look exactly like these ones here. So I have 4 over x, 7 over 2x squared. So once you are plugging x to the infinity, once you are saying x approaching infinity, all of these values will become 0. So this will be equal to minus 2x to the power of 5, open bracket, 1 plus 4 over infinity plus 7 over 2 infinity square plus over infinity to the power of 5. So because these numbers, the denominators are going to get so big and these values are going to approach 0. So I'll just say this is 0, this is 0, this is 0. So that here I have minus 2. Remember, I'm supposed to plug in the infinity sign, or 5. And then this is 1 plus 0 plus 0 plus 0. So plus 0 plus 0 plus 0. From here, I know that infinity to the power of 5 is still infinity, times minus 2, which is minus infinity. So minus infinity times 1 is still minus infinity. So let's look at another polynomial problem. So this is another polynomial example that you can pause the video and solve this one yourself. Like we did before, we look at the function we are given. So the function we are given here is x squared minus 2x. Since this is a polynomial, let's factorize the one with the highest term. So I would say limits, I'll write this as limits x approaching infinity. The term with the highest degree here is x squared. So x squared, open bracket. If you factorize this out of this, we have 1 minus 2x over x squared. Such that we can still rewrite this as limits as x approaches infinity is x squared, open bracket, 1 minus x, 1 here, x. So I have 2 over x. Now remember, my next step is to plug in my infinity value. So I'll get the limit as x approaches infinity. The limit as x approaches infinity is infinity square, open bracket, 1 minus 2 divided by infinity. Because we have 2 over infinity, if we have a number so big, this number will be approaching 0. So this will be 0. And then this will be equal to infinity square. And then 1. Infinity square is infinity times 1. That's infinity. Here is a shortcut on how to find the limits to infinity of a polynomial. If you have a polynomial, say x to the power of 6 minus x to the power of 7 plus x to the power of 8 and plus 6x4 and or things like this, the thing you should be looking at is the one with the highest power. So the one with the highest power here is x to the power of 8, which is meant to be this one. If you just take that one to be x to the power of 8, take the sign on that one, and then you plug in your infinity value. So if you're asked to find the limits as x approaches positive infinity, we have plus x to the power of 8. You simply plug in your infinity sign into this. So you have plus, open bracket, infinity sign to the power of 8. So infinity times the power of 8 is still infinity. This was a negative infinity sign, where say we are asked to calculate x approaching negative infinity. We simply take the highest one, like we did, and say plus, open bracket, negative infinity to the power of 8 is equal to negative infinity. Now this power here is an even numbered power, so it becomes a positive infinity, right? That's a simple shortcut. But if in an exam setting where you're asked to solve, you want to do it like this. In an objective setting where you don't have much time, you can do it like this to save time. So let's look at more questions that have more rational functions. Let's talk limits to infinity and negative infinity of rational functions. If you notice, this one has a polynomial on the numerator and a polynomial on the denominator. To solve this kind of problem, we look at degree. By degree, I mean that as you have this x here, the degree here is 2. If you have this x here, the degree here is 1. As you have 6 here, there's no degree because there's no variable here. Here you have 6x, the degree of x here is 1. That's the power. The degree is simply the power. Okay, you have, this is supposed to be 5x squared. And then here you have 2x cubed. The degree here is 3. The degree here is 2. So to solve this kind of problem, you pick the value with the highest degree on the numerator. So the highest degree here is x squared, and you factorize it from there. And then the same thing for here, the denominator. You pick the 2x squared and you factorize it from the whole thing. So to do that, I'll simply say, rewrite this as the limits as x approaches negative infinity. So the highest degree term here is x squared. So this x squared, open brackets. As I factorizing x squared from this, it becomes 1 over x plus 1 minus 6 over x squared divided by, then you factorize 2x cubed here. Factorizing 2x cubed here, this becomes 2x cubed, open brackets, 3 over x squared plus 5 over x plus 2 plus 1. These two terms can come together such that the limits as x approaches negative infinity can be written as 2x cubed times the bracketed terms here. So this is 1 over x plus 1 minus 6 over x squared over, this is 3 over x squared plus 5 over x plus 1. Now there's a rule in limits which says if you have the limits of x approaching a value, say a, and then you have a times b, you can individually take the limits and say limits of x approaching this value of a times the limits of x approaching the same value of b. So this is a law of a limit. So this is also equals to this. So that means I can take the limit of this one individually and multiply the results by the limit of this one. So that I'll write this as, because of that rule, I'll write this as the limits as x approaches negative infinity of x squared over 2x cubed. I can break this down. This is 1, and then this is x times the limits as x approaches negative infinity of 1 over x plus 1 minus 6 over x squared divided by 3 over x squared plus 5 over x plus 1. So from here, we have, I'll take the limits here already. So if I take the limits here, remember I have 1 over 2x here. So it will be 1 over 2 minus negative infinity times, if I take the infinity terms here, this will be 1 over negative infinity plus 1 minus 6 over negative infinity square over, then I have 3 here over negative infinity plus 5 over negative infinity plus 1. All the 1 over negative infinity, you know, they go to 0. So this one is approaching 0. 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 So what we have here is 1 over 1. This one is also approaching 0. So this whole term is approaching 0 too. So I have 0 times 1 over 1. So I have 0 times 1. 0 times 1 is also 0. So this limit here is approaching 0. Let's take another example. So for the second example, we are asked to find the limits as x approaches positive infinity of x squared minus 9x plus 1 divided by 3x squared minus 2x minus 15. So to solve this problem, for the numerator, we factorize the term with the highest degree out of this numerator. And for the denominator, we factorize the term with the highest degree out of this denominator. So for the numerator, the term with the highest degree is x squared. So I'll write this as limits as x approaches infinity. So this will be x squared, open bracket. If I'm factorizing x squared from x squared, it's be 1. I'm factorizing x squared from 9x, it's be minus 9 over x, plus I'm factorizing x squared from 1, it's be 1 over x squared, divided by the term with the highest degree here is 3x squared. So I'll be saying 3x squared, open bracket. Factorizing 3x squared from 3x squared is 1. Factorizing 3x squared from minus 2x, we have 2 over 3x. And then we have 5 over x squared. Like I did before, I can side separate these two. So this will be the limits as x approaches positive infinity of x squared over 3x squared. Now this can cancel out this, times the limits of the brackets as x approaches positive infinity of 1 minus 9 over x plus 1 over x squared, divided by, open brackets, 1 minus 2 over 3x minus 5 over x squared. So I'll take the limit as x approaches infinity for the two functions. So as I'm taking the limit here, this is 1 over 3. So the limit as x approaches infinity of 1 over 3 is still 1 over 3 times here. This will become, open brackets, 1 minus 9 over infinity, 1 over infinity square, divided by 1 minus 2 over 3 infinity minus 5 over infinity square. So this will tend to 0. This will be approaching 0. This will be approaching 0. This will be approaching 0. So what I really have is equal to 1 over 3 times 1 over 1. 1 over 3 times 1 over 1 is still 1 over 3. So that's how to solve problems on limits approaching infinity and negative infinity of rational and polynomial functions. If you liked the video, leave a thumbs up. Subscribe to the channel, it really helps. And share with your friends. Thanks for watching.